Exponents. What are exponents? What do they mean? Well, for example, what does 2 to the third really mean? We know what it is. I think 8, my favorite number, but it means 2 times 2 times 2. Or 5 to the fourth means 5 times 5 times 5 times 5. It's just a shorthand notation for repeated multiplication. Thank you. Radicals, on the other hand, answer a slightly different question. So for example, if you wanted to take, say, the cube root of 64, well, first, some notation. Oh, thank you. The 3 right here is what's called the index. And the radical symbol is the radical symbol. Thanks. So what is this really asking? Well, we look at the index, which is 3, and the question then becomes, what is the number that if you multiply it by itself 3 times, you get 64? So that's the question I'm always thinking of. What number multiplied by itself, in this case 3 times, equals 64? Well, in this case, it's going to be 4. The cube root of 64 equals 4 because 4 times 4 times 4 equals 64. And in the same sort of way, let's pick this one. The 5th root of -32 equals -2 because -2 times -2 times -2 times -2 times -2 is -32. Question? Can I zoom in a little more?
Yeah.
Sure. So I'm going to try and zoom with this because as my boss pointed out, this does have a manual zoom. You just get closer. How's that? Cool. The extra visuals about. Okay, so those are the rules for exponents and radicals. An exponent at its very basic level just means repeated multiplication. A radical is just kind of the undoing of that, right? You're asking the question, what do you multiply by itself so many times to get such a result? And then we have some rules about exponents. Specifically, these are all under the kind of heading of the additive law of exponents. It's called the additive law of exponents because what it is when you multiply, say, x to the a times x to the b, you add the exponents together if the base is the same. So x to the a times x to the b is just x to the a plus b. And I kind of